Good morning, ma'am. ஒருமைக்கண் தான் கற்ற கல்வி ஒருவருக்கு ஏழ்மையும் ஏமா கிடைத்து. Vanakkam and very good morning to one and all present here. Education is not just about going to school and getting a degree. It's about widening the knowledge and observing the truth about life. By Sakuntala Devi. With that quote, let's start the day with Tamil Life.
நீராறும் கடலுடுத்த நிலமடங்கு கேழொழுகும் சீராறும் வதனமென சிவபரத கண்டமிகு தெக்கணமும் மதில் சிறந்து திராவிடனல் திருநாடும் தக்க திரு திருநுடலும் தரிசனரும் திலகமுமே அத்திலக வாசனை போலனை துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்து பெரும் சமயனங்கே தமிழனங்கே உன் செய்திலமை திரும்பி எந்த செயலருந்த வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
Thank you, Swati. I would like to extend my warm greetings to one and all present here. I invite Mrs. K. Prasanna Lakshmi, Head, Department of Mathematics with Computer Application, to deliver the welcome address.
A warm good afternoon to one and all present here. I begin by quoting Oprah Winfrey. Quote, "You don't become what you want, you become what you believe." Unquote. It's a glorious moment to extend a warm welcome to everyone on behalf of the Department of Mathematics with Computer Applications to our annual association fest, KRYPTA. KRYPTA has made us to find a new way of conducting our association from face to interface. KRYPTA 2022 brings the best in students' potential and highlights the way to adapt the new normal. I am delighted to welcome our esteemed chief guest for today's session, Dr. Mrs. P.L.Chithra, Professor, Department of Computer Science, University of Madras, Chennai. I welcome you, ma'am, and thank you for accepting the invitation. Today
It is my pleasure.
Thank you, ma'am. Today she would be sharing with us on the topic recent research trends in image and video processing. I would like to welcome our Honorable Principal Ma'am, Dr. S. Koday, who has been a pillar of support in all our endeavors. Next, I would like to welcome our beloved Vice Principals, Vice Principal Aided, Dr. Usha Rani Ma'am, and Vice Principal Self-Supporting, Dr. Usha Priya Ma'am, who have been a constant source of inspiration. Next, I would like to welcome the heads of the other departments, faculties of other departments, and other participants who have joined us for today's session. Last but not the least, I would like to welcome my beloved students who are participating in today's session. Welcome one and all. Thank you.
Thank you, ma'am, for your speech. Now I invite Ms. Divya, Student Association Secretary, to introduce the chief guest. Thank you. says it's not just about what you accomplish in your life, it's about what you inspire others to do. Our chief guest of the day, Dr. P.L.Chithra ma'am, is a living instance of this quote. Dr. P.L.Chithra ma'am, who is a professor in Department of Computer Science, University of Madras, holds a PhD degree from the University of Madras titled Multi-Resolution Based Image Course for Lossy Lossless Compression. She has 30 years of teaching experience and 21 years of research experience in computer science. She has indexed 82 international publications, including SCI, ACM, Springer, Scopus, and international level conference papers. She has also chaired numerous sessions, conferences, and been a part of many IT workshops, technical sessions, both in academics and industry. She has published more than 96 papers in national and international reputed journals with 70 citations. She has been a member of Board of Studies at various colleges like Stella Maris College, Women's Christian College, Lila College, and Ethiraj College for Women, both UG and PG Computer Science. Her areas of specializations are digital image processing and patent recognition. She has been the speaker of National Conference on Recent Trends in Intelligence System held on March 2015. She has been the coordinator for IDE, MCA, and MSc IT course in Madras University for 3,000 PG students during 2001 to 2004. She was also a coordinator for the special lecture on promotion of innovation and entrepreneurship organized by Department of Computer Science, University of Madras, and also for conducting UGC NET-SLED coaching for SC, ST, and OBC students, University of Madras, during 2014 and 2015. She was awarded University 4th rank in MCA in 1999. She has received UGC FIC Award in the year of 2007 to 2009. Best Paper Award in National Conference on Recent Trends in Intelligence System and BD Good International Scientist Award, BGIAC 2019. She has also received Felicitation Award at Ethiraj College for Women. We warmly welcome you, ma'am.
Thank you for your kind words.
Thank you, ma'am.
So, good afternoon, everyone. Happy afternoon.
Thank you, Divya. Ma'am, I request you to take over the session now. Thank you.
Yes. So, happy afternoon, everyone present here. I am happy to join with you virtually in your association, Department of Mathematics with Computer Applications KRYPTA 22 Annual Association Festival at Ethiraj College for Women in today's session, inauguration function. So, respected head of the department, beloved students, principal, vice principal, I am happy to take part in this program. First, let me tell you one thing. I have worked at Ethiraj College for Women during 90 to 2000 in the Department of Computer Science, Ethiraj College for Women. So you can make me as an Ethirajian. I was in the family of Ethirajian. It is my pride to reveal in this moment. So today, I thank the organizers for having given me the opportunity to interact with the young minds to introduce about recent research trends in image processing and video processing. So you belong to mathematics and computer applications. This is one of the very good combination. We can do lot of wonders with respect to computer science. It's strong mathematics background only. We can do lot of efficient programming and we can march towards our research. This is actually a good combination. So all of you be happy to be associated with this department. Since you are learning mathematics and computer applications, that will lay down a basic foundations to go with the long mile to do research and good programming in this domain. Shall I share my screen now? Let us make this as an interactive session.
Yes, ma'am. You can start, ma'am.
Mm.
Thank you for joining us, ma'am. Thank you, ma'am.
Yes, yes. Can you see my screen, all of you?
Yes, ma'am.
Yeah. So happy to be part of in this program. I'll start my session based on recent research trends in image and video processing. If we have anything to be clarified, make it as an interactive session. Okay, fine. A picture is worth more than 1,000 words. Do you all agree with me? Can I have the response from the other side? Yeah. Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great. This is said by our Dr. APJ Abdul Kalam ji. So it is highly true that always learning leads to creativity. Creativity leads to thinking. Always thinking provides knowledge. So knowledge makes you great. So every day we need to learn, and become a great personality in the world. I wish you all the best for this happy learning program in your KRYPTA inauguration function. The overall agenda of this program is to talk about what is an image processing, why do we need image processing, then what do you mean by digital image processing, video processing. So this particular content has been referred from Digital Image Processing by Rafael C. Gonzalez and Richard E. Woods. This is the older version of the book. Now recent version is available. 9th edition is available. So then we have referred another book called as Machine Vision, Automated Vision Inspection and Robot Vision by David Wieman, Prentice Hall, 1991. It is available also online. Those who wants to become a very good image processing scientist, please go through this. The focus of this session is to talk about what is an image, right? What is a digital image? What is a digital image processing? Applications of digital image processing, then examples of digital image processing, recent trends in image and video processing. Can I have some uh, uh, ideas about what is an image from the virtual gathering? Can anyone tell me what is an image?
Something picturized, man. A picturized actor.
Yeah, pictures, right? Any other definitions? Do you know that? Where are you using images in your day to day life? So, everyone likes pictures, right? Everyone likes images. For example, if you want to celebrate the birthday party of your friend, what you do? You will go and do the cake cutting, and immediately you will take snapshot and you will share to your friends group, right? It is just a simple example of you are using every day with an image, right? So similarly, you can take a video of your birthday party, and can share it to your friends immediately. If you want to do all this, we need what is an image, and people must be knowing multimedia, right? Multimedia is nothing but audio, video with images. Now we have sat together, right? We are sitting together in this virtual gathering only because of this image video processing along with audio and video. That is, video conferencing is possible with respect to our YouTube, right? So this is one of the media in which we can communicate virtually in terms of audio, video, and images, as well as we can see, if you want, you can see and share some videos also. So this itself is in need of to learn about an image, right? Just I am going to give some perspectives of what is an image and how are we going to use in our research trends. So image is nothing but visual representation of something. So that is, whenever you want to picturize a scene, you can immediately represent with the help of the sensor like camera, and you can take your snapshot. Now everyone is having a laptop like mobile with you with high-end resolution camera. You can simply snapshot by clicking, right? So that is visual representation of something. An image, mathematically we can speak, right? When you represent any data in the processing, we need to talk about data structure. The image is a two-dimensional array or a matrix, right? So matrix, as you all know, it's a two-dimensional matrix which comprises rows and columns of pixels. What is a pixel? Can anyone tell me? What is a pixel?
Clarity of the camera, ma'am.
Picture elements arranged in columns and rows. Two-dimensional function f of x comma y, where x and y are spatial coordinates, and the amplitude of f at any point of coordinate x comma y is called the intensity of the image at that point. So as I have said you, image is nothing but a two-dimensional array that is in the matrix form of pixels, which comprises x position and y position in the spatial coordinate with the help of the Cartesian coordinate system, and the amplitude of f at any part of the coordinate is called the intensity of that image at that point. When you have a snapshot of green rows, right, you will be having green color. For example, if you have some color, for example, red rose, if you want to have a red rose, you can have a red color on the foreground, and background you can have some color. That color representation is nothing but amplitude at the pair of the given x comma y position is called the intensity of that point at that point. When x comma y and amplitude are available, then we can represent it as a digital image. For example, this is a small grid of two-dimensional matrix with respect to a grayscale image of, for example, we have 32 rows and 16 columns, right? This could be given with respect to x and y. So here, the normally in the Cartesian coordinate system, bottom left is called as a origin, but whenever you talk about the monitor or any device, top left position is considered as origin, 0 comma 0. This position is called as a origin, top left, right? Here we have x axis and we have y axis, which consists of 32 rows and 16 columns. With respect to this, if you want to take one particular pixel at this position, this is nothing but f of 27th row comma 7th column, which is nothing but black color. When we represent a black color, it is represented by a value of 0. That is, 0 represents a black pixel. Then if you take another pixel, here that position x comma y is given as f of 29 comma 16, which is nothing but 190. That is gray value. This is called as a grayscale image. Here the grayscale ranges from 0 to 255, right? So based on this, we can represent a image. So I hope all the people would have understand how to represent an image. With this, let us move on to the different types of images. So here we have binary image, grayscale image, color image. So people talks about all the three types of images. What is a binary image? It is nothing but 0 and 1. Gone are the days, right? People are using only binary images, 0 or 1. If the particular pixel value is 0, it is black. If it is 1, it is white. So that is called as binary image. It contains two pixel elements 0 and 1, where 0 refers to the black and 1 refers to the white. This image is known as monochrome. As you know, it is called as a monochrome image. So here we can see some combination of zeros and ones, just like some small tree representation. Here you can see one particular pixel. So here that particular location is being expanded based on the color representation. Whenever there is a white part in this place, you will be having 1 1 1. The rest of the places you have zeros. This is nothing but a binary image representation. Are you all with me?
Yes, ma'am.
Yeah, good. So now we are just describing about a binary image in the particular portion. So grayscale image, it has 8-bit representation. That is 256, 2 power 8. It starts from 0, right? Therefore, 0 to 255, including 0, it will have 255 resolution value, 256 different shades of colors. 0 stands for black and 255 stands for white and 127 stands for middle gray, right? We have different shades of grays will be available: light gray, dark gray, black, zero, then white, nearing white. These shades will be given in the grayscale image, right? So here, as I told you, the grayscale representation goes from dark black, then lighter shade of darker shade of black, till lighter shade, it goes lighter shades, then goes up to white intensity. So to 8-bit representation, if you represent a pixel in the grayscale image, you require 8 bits per pixel. Therefore 2 power 8, it starts from 0. So that resolution is given 255. Different shades of colors are present. 0 stands for black, 255 stands for white. For example, 127, it lies in between 87 and 167, that is gray color, right? This is a different versions of shades of colors from black to white that has been represented with the help of grayscale images. So this is a small checkerboard. You can see this is a grayscale image. From this image, you can take some image like this, and from this particular position, we can represent a grid of pixels, two-dimensional array. So wherever black is there, it will be 0. The remaining portion, the different shades has been. This is actually a pixel value representation. In the rightmost corner, it is given 170. That particular gray value is given as 170. Then 236, 86, 255. 255 means white. White right represents the 255. The left side second pixel is 238. You can find the different versions of white. Then 221, slight change in the color. 0, black. Wherever there is 0, you can see in the given row, black and white along with different shades has been given. This is just scale version of grayscale version of the given image in terms of shades. It is being given in this particular diagram. So do you understand? So whenever we want to represent any pixel in the grayscale image, we require 8 bit per pixel. For example, if you represent a black and white, you require only 1 bit per pixel, right? So when you have 100 rows and 100 columns, how many pixels are, what would be the size in terms of bits? If you have 100 rows and 100 columns in the grayscale, how many bits are required? Can anyone tell me? 100 rows, 100 columns, along with 8 bit per pixel. So how much storage size is required in terms of bits? Got it? Can you tell me the answer, anyone? I hope everyone is listening to me.
Yes, ma'am.
Yeah, 100 rows and 100 columns into 8 bits per pixel. So how many bits totally required? 100 into 100 is how much? 10,000 into 8. Therefore, 80,000 bits are required. 80,000 bits. What is 1 byte? 1 byte is equal to 8 bits per pixel, right? Therefore, 10,000 divided by 8 bits, that much number of bytes are required to represent that particular small piece of the image, 100 rows, 100 columns, right? So we have another type of image known as color images. Here, famous RGB, red, green, and blue format. This is a primary color. In Java itself, you would have used some AWT, abstract window toolkit, under which you will be using different classes, right? Color, then font. So in the color object, you can create. So the primary channels available are red, green, blue. It has 65, 536 different colors with 24 bits. That is, red channel contains 8 bits per pixel. Green channel contains 8 bits per pixel. Blue channel contains 8 bits per pixel. So totally, for any triplet is required to represent a color pixel. Triplet, red, green, blue. So each comprises 8 bits. Therefore, we require 24 bits. Why do we want to learn all this? When you want to do some research, it is essential to know how to store an image and what are the different types of images. Then based on that only, we can work on it, right? For that purpose only, I just throw light on what is an image, what is the data structure to store an image in the memory, and what are the different types of images. We have just seen binary, then grayscale and color images. So totally we require 24 bits per pixel for any pixel in the color of the given f of x comma y in the matrix form, right? So this is what we need to know. So see here. So we have a good combination, different shades of uh, bird is given, original image, then original image is being shown with respect to the combination of red, green, blue format. Then this red channel alone is displayed here with the help of the same bird. Here red channel, then green channel and blue channel. So whatever the channel value is present, right, depends on the value, that particular intensity. This is one channel, that is 100 rows, 100 columns. Here 100 rows and 100 columns of red portion of this particular image has been shown here. Then 100 rows and 100 columns of green portion of the original image is being displayed here. Then we have blue channel of the same original image with respect to 100 rows and 100 columns. Why do I say that 100 rows, 100 columns? Just an example. So we have one small matrix with 100 rows and 100 columns in which we are going to display some image with respect to number of pixels. Each pixel comprises the shade intensity based on x comma y position. For each position 0 comma 0, what is the value? 0 comma 1, what is the value? 0 comma 2, 1 comma 1, then 5 comma 10, similarly 99 comma 99. Since it starts from 0, it goes on up to 99th row, 99th column, right? So based on this, we will have this image like this. So this is an example for the original image, then pixels. For example, the portion of this particular portion alone has been taken. This particular wood portion alone has been taken. And based on that, we have given you the pixels here. So that value is red portion present is 155, green portion is 131, and blue portion is 33. So we want to live with images. We are now living in the age of internet. We want to transfer the images from one place to another place. We want to work with computer vision. We want to use our artificial intelligence to our system to impart knowledge. We are going to show some cat or dog to the system, and we want the system to think and give the answer as, is it a dog or is it a cat? If we want to do all this, we require this type of applications, right? So we need to know the basics first. For that purpose, I'm just focusing on what is all about an image and how to represent an image. This will lead to a different thinking about what are the various research avenues which you can proceed with this. Red 155, green 131, blue 33. So with this, we can represent a color image. So then we have another type of image known as multispectral images. If you have any doubts, you can stop me at any time. I'm happy to answer you, right? So now we just proceed to the next type of image known as multispectral images, collections of several monochrome images of the same scene, each of them taken with a different sensor. So we have RGB image, then the same image could be captured with the help of different sensors, and that could be merged to get the multispectral image. So this is a multispectral image of this particular RGB portion, and this is a multispectral image with hyperspectral images. So if you make it as a entire thing as merged together, it is called as hyperspectral image. So this is another type of image which we can work on with respect to images. I hope everyone is comfortable till this. We have just proceeded. So we always need to know, right, dimension. Dimension is nothing but measurable extent of a physical quantity such as length, breadth, depth, or height. So this is a one-dimensional image. So just a straight line or something like called as a loop. This is called as one-dimensional. That is array of set of elements with the same one parameter, right? So one scalar, it could be scalar. Two-dimensional. What do you mean by two-dimensional? It can have height as well as width. So what is a height? This is a height portion, then width or breadth, right? We can say it like this. So this is nothing but a two dimension. Two parameters are required. These are all the geometric shapes which you have learned: a square, or we can say triangle, or we can say some circle. All these things are coming under two-dimensional space. Then we have three-dimensional space, under which we need to talk about length, breadth, depth. The height of the particular object is required. That is called as three-dimensional. So we need to know about the length, breadth, along with height. If you know all these three parameters, then we will say that is coming under three-dimensional domain. So we need to know the dimension, right, of the given image. When you talk about any audio signal, it is called of 1D nature, one dimension. If you take any image, it must be of two-dimensional nature. If you take any video, or if you take any image from MRI or CT, it will be coming under the three-dimensional. So you can see 2D to 3D. So you can have a 2D image like this in this left side of this thing. Then after which, if you add on some colors and if you give some depth along with the given image to make more reality, then you will be having 3D representation. Any 2D representation could be converted to a 3D model. So now people are working more on 3D models in computer vision, and it leads to different applications, interestingly, in research. So with this, I have just given digital image. Then what are the different types? So it could be represented in another perspective. A digital image is a representation of two-dimensional image as a finite set of digital values called picture elements. What do you mean by finite? What do you mean by finite?
Countable.
Yeah, countable. So when you have 100 rows and 100 columns, definitely there are 10,000 pixels only, right? So countable. It's a representation of a two-dimensional image as a finite set of digital values called picture elements or pixels. So how do we capture an image, right? It is very interesting. You need to know what is a digital image you have learned, and you have known about the different types of images. How are we going to capture an image? It is very important. We need some modality. Modality is nothing but camera. Simple example, camera with sensors. So we have an object like this in this diagram. We have some illumination source. So some light is required, right? And it should be incident on the particular object. Then it will have to absorb the light by the object, and it reflects through some imaging system like camera or MRI scan or CT scan or whatever the different modalities available. Based on the sensors, it will get reflected onto the screen. that is called as monitor, screen or monitor. Based on this, we will be getting an image. So this is nothing but an image. So we have a eliminating source. Through the eliminating source, that will be incident on the object which has to be captured. It will absorb, and based on the imaging system, it will get reflected on the device coordinate, and based on the device, it will get you a approximation of the digital image. What do you mean by digital? People are saying about analog and digital. Analog means continuous signal, digital means discrete signal. So here this particular device has been discretized. Discretized means we can represent the pixel values. If you take the particular element here, the light shade of the particular grayscale, that has been shown in this middle portion of this object. Everything is given as a small square, right, based on the aspect ratio. Therefore, there is an approximation of the object that has been captured in this digital image, right? This is the output. So when now we have digital cameras with us, we can take the camera and we can use the camera and we can digitize the image immediately, and we can get the pixel values. Or we can use some image editing tools or MATLAB tool or Python to read an image, right? Or even you can use Java and you can work on it with this, right? So with this, I have shown you a pixel with a given object, and that has been, for example, you see here the corners, edges have been approximated now. Though it is being only the portion of this, only 50% of the edges are only contributing this object in the left side or the original image. But while digitizing, we are taking the entire pixel, right? And that has been approximated. Edges will always be approximated like this in our digital image, right? Digitization implies that digital image is an approximation of a real scene. So as I already told you, approximation of real object is being shown in the second diagram, right? Now let me give a small example of deer which is sitting on the grass, and if you want to see the thorn of a particular deer alone, you can simply see this one pixel, and that color value is a triplet with red, green, blue format, or we can use some other color model also, reduced color model in different way. But we are now representing red, green, blue format as a triplet for this particular portion of this particular image. It could be seen with respect to a digital image, right? Pixel value represent gray levels, colors, heights, opacities. Gray levels, it's a black and white. It's not black and white. It is just a grayscale image with different shades of black and white. Color means color images. Height means when 3D representation is coming, we require this height and opacities, right? With this, we can find the element. This particular portion alone has been shown in this last diagram, which has been given here. So with this, we are just getting through our fundamentals of how to represent an image. We have lot of examples available, and we could do lot of research in this image processing in the day-to-day life. It would be useful for the society also. That we will see soon, right? In the next slides. So common image format include one sample per point, as we have seen in black and white or grayscale, right? One sample per point. Then 3 samples per point for color, red, green, blue. 4 samples per point for red, green, blue, and alpha. Alpha is nothing but opacity. For example, the same image which has been shown here with respect to first grayscale image, then middle portion shows the particular scenery with respect to red, green, blue format. Then the last diagram in this particular image shows that it is alpha portion is also present. What is alpha? Opacity. That is 3D view of the water flow has been shown here in this particular image. So this is, you need to know. Black and white, how many samples is required? Red, green, blue, 3 samples. When you represent any 3D effect, it must have 4 parameters, red, green, blue, along with alpha. Alpha represents opacity of the particular position of the image, right? Depth is given. So what do you mean by image processing? So when you learn digital image, if you want to process a digital image for some meaningful purpose, it is called as digital image processing. Now I am taking a snapshot of this particular classroom, and while taking the snapshot, I would have seen some just I am just shaking the photograph, right? Then my picture will not be clear. So what I can do is, I can take that particular picture, I can use my algorithm under which I can improve the pictorial representation for human interpretation. So that is a simple example of processing. So processing focus on two major tasks: improvement of pictorial information for human interpretation, then processing of image data for storage, transmission, and representation for autonomous machine perception. What do you mean by that? For example, you want to take your birthday party video and you want to send from your source to destination, then to one friend to another friend, then it has to be transmitted only in the internet, right? While doing that, it is a need of storage transmission as well as data for storage transmission and representation for autonomous machine perception. These are all the some examples for compression is required, in that which we can do effective transmission with effective storage. That we will see. When you take any MRI image, it may be poor in nature. It could be pre-processed with the help of using image processing algorithms. So with this, the image processing to computer vision can be broken into three stages: low level image processing, middle level processing, and high level processing. What is low level processing? If you take the input as image and if you receive your output also again another image, then it is called as low level process. For example, noise removal. When I shake the photograph while taking, I can improve it either using smoothing or sharpening effect. For that, I have to adjust the contrast. If I do that, it is coming under input is image, output is also improved image. That is coming under low level process. That is coming under low level process. Examples: noise removal, image sharpening. So the second category is known as middle level process. We can give image and attributes. For example, I can give the traffic, under which I can identify how many cars are present. Under the car, I can identify where is the license plate. So based on that, who violates the rule could be easily monitored and we can put the penalty. For all this, we require mid-level process image attributes, right? We can extract attributes from the image after processing using an algorithm. So that is coming an example for mid-level process. All object recognition, segmentation, region of interest, right? When I take only the foreground of the given image, rose flower, I want only rose flower. I don't bother about the background. That foreground, if I take it, I need to apply the segmentation. So this is called as mid-level process. Third one is called as high level process. So we now live in the age of artificial intelligence. What is intelligence? We import knowledge to the system by means of production rules, and based on the production rules, we make our system to react. But our system is always machine oriented, right? It is a dumb machine. It cannot do anything on its own. It is just a hardware, bare machine with some operating system. Along with, we have some softwares associated with it. With the help of our programming, we be able to instruct the system to do some action. But it is a dumb machine. It can understand only zeros and ones till today, right? So if you write some production rules and if you write some AI algorithms, our system will react and it may simulate like a human being, right? So for that, we have high level process. That is coming under high level process. This is part of computer vision. Attributes output. So once if I give attribute, for example, I can give the pixels of the cat image as a color and texture. That could be extracted as attribute and that could be given as an input to my system, and my system can understand it and it can say, if I show dog, it says that it's a dog. If I say cat, if I show cat to the system, my system will get trained, and based on the neural networking and deep learning algorithms, it can automatically give the understanding of it's not a dog, it is just a cat. So this is coming under computer vision, scene understanding, autonomous navigation. For example, in defense, when you want to use autonomous navigation, even people cannot get inside, but a machine can get inside to do certain actions. For this, we require high level process, right? With this, we are just moving on to the recent research trends in applications. Recent research trends in applications. So let me go fast, right? So we need to focus more different applications, more types of applications. Just I'm moving on. This may be called as early 1920s. One of the first applications of digital imaging was in the newspaper industry. Partline cable picture transmission service has been shown. Images were transferred by submarine cable between London and New York. First newspaper industry only has made use of this particular technology to transfer the pictures from one source to destination through submarine cables. So this is during 1920s. So next, mid to late 1920s, improvement to the Bartlett system resulted in higher quality education. So people have made with some more better hardware, and they have produced some good toner images during mid late 1920s. 1960s, if you see some images, a picture of the moon taken by the Ranger 7 probe minutes before landing. So satellites and everywhere, all the people are using only this camera, and it captures images. It will take that image from that station to Earth station, and people will work on it. So computers used to improve the quality of the images of the moon by the Ranger 7 probe. Such techniques were used in other space missions, right? So this is during 1960s applications. These are all the trends in which we can work on today also as a good research, and we can contribute some societal value to the applications for the mankind, right? 1970s, digital image processing begins to be used in medical applications. It is one of the very great potential field in which our image processing people can contribute much to the society. So when the radiologist is taking an image, and the image machine modality itself gives you what is the image and how it looks like inside the body, right? Then if there is any tumor present, whether it is malignant or benign, that could also be analyzed based on the position of the image, texture, size, shape of the particular data which is present in the data, right? So 1979, Sir Godfrey N. Goudsfield and Professor Alan M. Cormor shared the Nobel Prize in Medicine for the invention of tomography. It leads to a different evolution of this technology behind computerized axial tomography. This is the basics. Their invention is the basics for CT. Based on that, they can capturize the images as CT image, right? In 1980s to today, we can use digital image processing techniques has exploded, and they are now used for all kinds of tasks in all kinds of areas, namely image enhancement. Enhancement is nothing but improving the pictorial representation, adjusting the pixel values. Then restoration is nothing but extension of enhancement. Here we use some mathematical model through which, when there is any gap available, it is missing, that could be filled up with respect to some interpolation techniques. That is called as restoration. Then we have artistic effects. What do you mean by artistic? So people are working on computer graphics. What is a computer graphics? CG. So when you take any movie from Hollywood or Bollywood, people are always talks about computer graphics, right? CGs. So all these things are coming under. So when the hero wants to jump from the 1,000-meter altitude, he cannot jump directly in the real time, but he can make use of some camera to show him as he's jumping as from 100-meter or 1,000-meter aptitude. So that is artistic effects could be brought. Then medical visualization. What do you mean by medical visualization? If I talk about CT images and MRI, PET scan, for any scanning, it could be used. Then industrial inspection. In the industrial inspection, applications in the recent research trends are when you pack, for example, you pack drugs, it should be packed in proper way. That could be analyzed. Automated systems, law enforcement, as I have already told you, traffic monitoring system, who violates the rule, and penalty to be made. All these things could be easily done, and you can see CCTV footages of in all the signals in and around Chennai. If anybody is violating the rule, they will be they will be given the notice to pay the penalty, right? All these things are possible only with respect to the digital image processing applications. We can do lot of research during this, and we can contribute much towards this society. Example, what is this? Can you anyone tell me? First one, left side.
Ribcage, ma'am.
Yeah, it is nothing but a X-ray image, right? So here, can you see anything else from the first part? It is very dark. We cannot see any bones and other things present, right? Uh, but if you can take this input image as an X-ray image, but due to the radiation, it is harmful to the human body, right? So people will not give much radiation towards taking X-ray for the patient. What they do, they will give minimum radiation since it is not good for health. So they will give minimum radiation and get the image like this. But as such, doctor could not diagnose anything properly. As a computer scientist, as an image processing engineer, what we can do is we can just take this input image and we can make use of adjustment of pixels either by applying convolution using filters with respect to low pass filters for smoothing operations and high pass filters for sharpening effects. So when you want to know the light and the given bones and other things, we can easily do by processing this image. This is an input, this is a output. Can see the difference, right? This is an example in which we can work on it. This is one of the very good research domain, can easily work. Then another one is all electronic printed circuit boards. If you want to purchase any electronic component, it is made up of print electronic circuits that could be easily troubleshooted by the machine with the help of this snapshot. And if there is anything missing, maybe while taking it is not clear, after making use of this image enhancement algorithm, we can highlight the edges and we can give whether it is shouldered properly and whether will it work. In all embedded systems, we have chip enabled and we have program enabled, through which all this require this printed circuit boards. This printed circuit boards can be troubleshooted with the help of image processing applications. These are all the different domains, applications which we can work on. What is this third one? Can you tell me? The middle one in the second row. It's an aerial image, right? Yeah, satellite, through satellite, people have taken some drones, they would have taken the image, but it's not clear due to poor resolution, right? It's not clear. So what you can do is that particular lighter shade version of the aerial image could be mixed with some colors or making use of some adjusting pixels with adjusting the contrast. We could identify there are some water portion, there is a greenery, and there are some land with houses. All layouts could be easily identified. So these are all some domains. First domain, with algorithms we may apply smoothing and sharpening, and combination of both will help us to enhance the given image. So the next, the one is Hubble telescope. As you know, so when you want to know if there is a storm, right? So due to heavy rain during Chennai, right? At Chennai during the last before 2 months, so people have not unexpected, right? So that weather forecasting people would have given you all warnings. In spite of that, with the heavy rain, we could not manage, right, to live in Chennai with floated with water. All these things could be easily identified with the help of these images, and very distant objects could be captured with the help of Hubble telescope. While taking, due to the mirror positioning and lens positioning, it may not give the proper data like this left side, but it could be processed and we can make it as a perfect photo with respect to enhancement techniques, and we can get the information out of the enhanced picture, improved version of the given picture. So that is another example for image enhancement. So this Hubble telescope is launched in 1990, and can take images of very distant objects. However, due to the incorrect mirror position, it could not take images usefully. It has produced some images which is useless, but with the help of the image processing techniques, we can fix this and we can give the information out of it, right? This is yet another important applications for the society. As I have already told you, another example, artistic effects. So when you want to make a hero to be very young, right? Many old heroes could be shown as a young hero. For all this, we require artistic effects, CGs, right? So artistic effects are used to make images more visually appealing, to add special effects, and to make composite images. So when you want to take some risky shots and very interesting shots, all these things could be easily done with respect to artistic effects, that is coming under our another research domain. Then medicine, right? So when now we are living in the age of pandemic like COVID-19, and people are doing lot of research based on lung cancer and how much portion of the lung is being affected. All these things could be easily analyzed with the help of taking the snapshot of the particular lung. Then afterwards, we can use some edge detection method by means of using some filters, right? Sobel filter, literature itself, a lot of filters available. Based on that, we can either smooth it or sharpen it, and we can identify the uh, research towards the particular domain. So this is simple example of dog heart. They do some did research based on this dog heart. So but left side it is a input image. Afterwards, what they have done is, here only they have highlighted the edge portions, and they have made it as a edge detection. For that, they used a suitable filter to highlight edges. This is yet another important example in medicine. So medicine is in medicine, image processing people could play a crucial role and help the doctors to diagnose and identify to go for patient's treatment comfortable. This is a interesting and important applications. Medical image processing plays a vital role in research trend, right? People who wants to work with medical image processing, you can easily work with medical image data sets either by means of CT images or PET CT or MRI. You can take that snapshot, and whatever it is not given clearly from the machine due to the radiation or some other defect, we can easily process it and we can make a great invention out of our algorithms. GIS, right? What is GIS? Can anyone tell me?
Geographic information system.
Yeah, geographic information system. Digital image processing techniques are used extensively to manipulate satellite imagery, terrain classification, meteorology, smart city development. All these places, image processing sensors are playing a vital role to capture an image from different places, from different planner to earth station, and we can work on it. Whether is there Mangalyaan, is there any water present, or is there any living organ is present, or is it a rock, or is it a clay, or is it a which type of mineral is present. All these things could be easily analyzed by means of the capturing the data from their Mangalyaan, and it may send to our earth station. Earth station people can analyze, right? NASA people and other people could sit and analyze, and they can just give you a data which is present in the particular image could be analyzed comfortably with the help of GIS system. So weather forecasting is yet another important applications in the satellite imagery and terrain classification. All these things are playing a vital role in our day-to-day life with respect to. You can take up this as one of the research topic, and you can work on it further, right? So basically, people would like, right, to have a hobby of watching the stars at the night. Might be this group also, maybe some of the people are interested. If I would have taken one to one, I would have asked you to show and raise your hand, right? So you would have told me how many of you having this habit, right? Interesting hobby with you. So with the help of this GIS examples, we can go with global inventory of human settlement with respect to nighttime light of the world data set, and not hard to imagine the kind of analysis that might be done using this data. So we can do lot of wonders with respect to this nighttime lights of the world data set could be analyzed with the help of the image processing applications, right? Shall we go to the next part?
Yes, ma'am.
Are you finding it useful?
Yes, ma'am.
Yeah. This is the industrial inspection. So as I have already told you, when human operators are expensive, right? Nowadays, everything is automated and mechanically maintained to reduce the cost and make it fast. Industries are moving on towards industrial inspection like this with automatic machines in which image processing applications are playing a vital role. These are all the research places at which we can contribute. Machines do this job instead, right? Then industrial vision systems are used in all kinds of industries. When you pack some bills or when you pack some liquid in, for example, if you want to do certain analysis based on blood samples in your microscopic images, everywhere we can do a lot of wonders with respect to our image processing algorithms. If you are really interested to work with this, electronic and communication people could focus on xerox machine like this and printer circuit boards, whether it is being uh, just made as properly one, right? In car system also, while production of car also, if there are a lot of boards available, ready made boards, all these things could be troubleshooted by with the help of the robotics, right? So based on this, we can do PCB inspection. So all these places, conventional imaging and X-ray imaging helps us, right? Machine inspection is used to determine that all components are present and that all solder points are acceptable. So in all embedded systems, whether it is done perfectly, could be troubleshooted with the help of PCB inspection. We can contribute in that domain also. As I already told you, now we have CCTV footages which has been uh, located in and around Chennai, and if you violate the rule, automatically your license plate will be caught and you will be immediately sent by the people to pay the penalty within a month or 3 months, right? So all these things are possible only with the help of image processing techniques which are used extensively by law enforcers. Number of plate recognition for speed, cameras, automated toll systems, CCTV footage analysis, enhancement of CCTV images. As you know, the poor resolution we could not know, and people are doing some mistakes, right? By showing or hiding the camera, and they do some mistakes. So at that time, we can easily do enhancement, right? And we can identify as a computer scientist, image processing application. We can do research and we can make what exactly it was present with the very light image. We can make it enhance it and we can understand what happened, right? Then fingerprint recognition, biometrics, everywhere people are working on it, right? Using it attendance purpose. So fingerprint recognition also, ridges and all these things, automated systems are readily available. This is also one of the very good interesting application in our day-to-day life, so in which we are working on various image processing techniques. These are all the avenues in which you can focus. Then human computer interaction, whether I'm just moving or I'm laughing or I am talking, all these things based on the given gesture recognition, all these things could be done. Face recognition, gesture recognition. For example, in our Aadhaar card itself, people are using iris recognition, then fingerprint. That is all your unique ID, right? It could be stored in your database and we can work on it. So when you have human computer interfaces more natural, all these things could be done with respect to human computer interface. Nowadays, due to pandemic, online exams are going on. So when we can see, make the people to switch on the camera and we can see the posture of the student, whether she's writing and taking up the exam seriously or any malpractice is going on, could be easily identified with the help of AI applications. It is possible with respect to human computer interaction. This is at another important field in which we can contribute. So at the nutshell, I can give you the overall idea with this. I will, I think within 2 slides, I'll completely uh, conclude the session, right? So, can I proceed? organizes,
Yes, ma'am.
yeah, research trends in digital image processing. So we have problem domain, image acquisition, as I already told you. So modality is required. Based on the modality, we can capture an image through some camera, high-end sensors or drones which are used. Then image enhancement. When the pixels are very poor in nature while capturing, it could be modified by either using smoothing or sharpening. With the help of filters, we may able to do the convolution operation. Through the algorithm, we may able to process and we can produce the output like this at the right side, right? This is called as improving the pixel values. Image restoration, as I already told you, when there is something like this, and when you have some museum and when you want to capture it, some old data, ancient data, but some of them may be decayed, but that captures mathematical model could be added through enhancement. We may able to have objective measure and subjective measure to identify and improve the pictures from image restoration techniques. So these are all different avenues people can focus on digital image processing uh, researches. Then morphological processing, as you know, in the fingerprint, we have ridges, and when you want to thicken the edge, you can apply dilation. When you want to thinning the ridges, you can apply erosion. This technique will help us with the help of the structuring element. We may able to apply the algorithm and we can do all this whether the fingerprint is personalized to a particular person. It is unique even for twins, as you know, right? So this morphological processing plays a vital role in different applications. Just I'm pointing out one simple application. Segmentation, we have two set of data and we can use some histogram application through which we can identify only the foreground, left side and right side portion. Based on thresholding, it is possible region of interest could be extracted, right? So this is another important place. A medical image processing plays a vital role to identify whether tumor is present or not. Object recognition, if you take a Irish data set, you have different types of Irish features available. The ophthalmologist can do all this analysis and they can find out what type of data which is present with three different clusters. They can analyze through the object recognition. This is simple example of object recognition. Even in traffic, we can identify the cars and vehicles and four-wheelers and two-wheelers. All these things could be done with respect to object recognition. Even our robotics can work on it. Then representation and description. If you have some pictures like this and if you want to know only the position of that points and if you want to analyze, for example, when you want to work with some tires and other things, you need this type of applications, representation and description, right? In 3D models, if you want to make it, this type of application is highly useful. So people can work on this research domain also while to work with 3D and other things. Compression is at another. So compression is another one. So which will help you to go for, as you know, RAR, zip, JPEG, everything you will be using while transferring the data from one your cloud storage of Gmail to another people. So this is coming under the, we have the compression models. Through the compression models, we can encode it and decode it without affecting the quality of the image. After reconstruction, we should get the original image, but it should occupy only less space. So we are the specialist in image compression. We have done a lot of work based on image compression, and we have applied almost all these techniques in our research area, and we have published more than 100 papers with respect to this domain, and we give some relevant useful contribution towards the society. Some of the papers for visually impaired papers, we have given some data applications, and we have done something for brain tumor detection, and we have done point cloud compression as well as point cloud data set for different real-time applications. All these things are playing a vital role in our research trends in digital image processing. So that is another one is we have this is color image processing. When you add on some false colors to identify what is inside the organ, everything could be done with respect to color image processing. So this is also playing a vital role when you want to work on medical images. Sometimes it is necessary to make use of this when isotopes have been given to a cancer patient. The doctor wants to identify, radiologists might use this coloring techniques to fill up and get the answers. We are also working on cancer imaging as one of the project. We do some nano app applications with respect to diagnosis and detection, treatment planning, everything we can do with respect to our real time applications. So these are all the different research areas. I think I have focused on this. With this, you can try. So far, we have been just explained what is all about digital image and how to work on it. So I have given some set of demos. I think you can see and how people are working on the industry. You can interestingly find out. Due to short of time, I'm leaving this to you. Please take this link and see. It's all available in the YouTube. You can identify how beverage industry is using, then how industry vision is using, then how our all the big projects are involving with this type of counting, image processing, vehicle counting in the traffic. All these things have been shown in this. A link has been given. Please see the link and you can see the demo later, right? So with this, we have also have got color models. So just I am focusing on what is a video. With these two slides, I just completed. Shall I proceed, ma?
Yes, ma'am.
Yeah, I'll take another couple of 5 minutes to complete this task, right? Please bear with me to give some more input based on video processing. Visual representations are often the most efficient way to represent information, right? So images are used in many scenarios like politics, advertisements, scientific research, military, etc. So video signals can effectively tell a temporally evolving story. What is temporal? So we have frames. Under the frames, we have frame 30 images per second. So based on our eye, we may able to see that 30 continuous images of the particular frame just like moving. So that is temporal. Time to time it keeps on moving. That only gives the picture motion, right? So that is nothing but our video, right? So cinema, surveillance, medical applications in which we are using video processing. So if you take any medical applications with the CT images or MRI or PET images, definitely you need to work on 3D images. So it is coming under video processing. When you take CCTV footages, it is a video. You need to work on video. It is nothing but frames. Each frame consists of minimum of some 20 to 30 images per second. So based on that, you can extract frame to images and we can work and we can come back to our video. So all these applications, whatever we have spelled out in the last 45 to 50 minutes, all these things could also be applied in the video stream. So CGs, everything motion pictures, right? So with the temporal. Temporal means time to time, it keeps changing the images. So these are all some examples which I have showed you. Sonar image under sea, how people are capturing and how the research is going on. All these things based on temporal images like video. The next one, sonar images playing a vital role. Military also people unmanned vehicle, everything could work with this. Tesla is using unmanned vehicle. All these things are possible with respect to lidar images and enhancement and restorations. As I have already told you, improve the contrast, blood things could be done based on different old and new. Can see the difference, right? Some adjustments could be made with respect to our algorithms. Then why do we need processing? The study of medical imaging is concerned with interaction of all forms of radiation with tissue. The development of appropriate technology to exact clinically useful information, usually in the form of an image from observed technology, CT, MRI, PET, etc. These are all 3D view of the given tissues. All these things could be easily identified and we can work on it. So then transmission and storage, as I told you, when you want to transmit images from one place to another place, some document everywhere, we need to work on compression. Then information analysis and automated recognition, recognizing terrorist. So it could be identified with biometrics, evidence, careful image manipulation can reveal information not present, detect image tampering, security and rights protection also we can use on image processing. So in all places, we can work on images. Just in this inaugural speech of this particular association, KRYPTA 22, I have just brought about recent research trends in image and video processing by throwing some light on how to represent an image, then what is an image, what are the different stages we can work on images, what are the different types of images we can play with that, and how do we contribute to the society. With this, I'm happy to close this session and I wish you all the best for your association activity. I wish I thank the organizers, your head of the department, Prasanna Lakshmi, and Mrs. Radhika, for having interacted with me, for giving me the opportunity. I take this opportunity to thank Ethiraj College for Women authorities, principals, vice principals, to everyone. Uh, my sincere gratitude towards the patient listening of my dear young, energetic students. I hope this particular session will motivate you to come and do lot of work with respect to our image processing. As I already told you, maths and computer science are playing a vital role in doing research. If you don't know the mathematical concepts, you cannot apply this in our day-to-day life image processing algorithms. So all this regression, statistical correlations, and probability distributions, linear algebra, vector algebra, everything married with our image processing applications, without which we may not be able to work. So with this foundation, you are the right person to come out by means of choosing any one of the area, and please do research and contribute. And if you come out with this idea, with I'm successful in this domain, I would be the greatest interesting happy person after throwing the light to this society, to this forum. Thank you so much.
Thank you, ma'am, for enlightening us with the great ideas in image and video processing. There is a question from a student, like,
Yes.
is there any course in which we can pursue further in digital image processing, ma'am? Is there any master's degree?
Yeah, basically, we can do master's degree. For example, we have lot of courses available under Swayam portal, right? Move courses available, under which we have NPTEL lectures, video lectures available, under which various professors have been focused on digital image processing itself. We, the Department of Computer Science, providing one of the course as digital image processing as a part of the PG program and the MPhil and the research scholar program. That way, I think you can learn it from NPTEL forum itself is giving you a great idea, right? That itself is enough. Self learning through NPTEL programming will make you to go to the greater heights, right? That itself will do. Or you can go with some image processing, image compression. Some foreign universities are providing. IIT is providing some image processing, computer vision, right? So computer vision and machine learning, that also covers this subject.
Thank you, ma'am. Thank you so much for patiently answering the questions, ma'am. Now I request Ms. Sumitra, Joint Association Secretary, to deliver the vote of thanks.
Can I stop, Sharma?
Ma'am. Yes, ma'am.
Good afternoon, ma'am. Gratitude makes sense of our past, bring peace for today, and create a vision for tomorrow. By Melody. Good afternoon, one and all. I deem it a great honor and privilege to propose a vote of thanks for today's virtual session on recent research trends in image and video processing. On behalf of the Department of Mathematics and Computer Application, we would like to thank our distinguished speaker, Dr.PL.Chithra ma'am, Professor, Department of Computer Science, University of Madras, for her excellent presentation and for making this session interesting and informative. Her exemplary explanation has given clear insight into the topic. We wish to express our sincere gratitude to the respected chairperson, Mrs. Chandra Devi Tanikachula ma'am, and the Board of Trustees for their constant motivation and support. We wish to express our gratitude to our respective Madam Principal, Dr. S. Kodai, Dr. D.B. Usharani ma'am, Vice Principal Aided, and Dr. P. Usha Priya ma'am, Vice Principal Self-Supporting, for their constant support and encouragement for all our efforts. We are extremely grateful to Mrs. K. Prasanna Lakshmi ma'am, Head Department of Mathematics and Computer Application Self-Supporting, for their valuable guidance, encouragement, and moral support. I extend my heartfelt thanks to all my teachers for their valuable suggestion and constant support. And I also thank Nitish Sri, Cultural Secretary, for hosting this event. Last but not the least, I thank all the students for their sustained interest in making this session a resounding success. Thank you, ma'am.
Yeah, thank you, one and all.
Thank you, Sumitra. Let's end this session with our college song. Thank you, ma'am. Thank you, one and all. Have a great day.
And thank you, ma'am.